Part of our discussion on QC procedures for the work that we're doing on retrofit and refurbishment has a lot to do with the rotating assemblies and the fan shaft work. Gary has been doing our evaluation on our new shafts. When new shafts come in and we're going to place these on a project, we have to QC them. There may be straightening involved, there may be flame spraying involved in having them reach the tolerances that we need. We have found that some of the fan shafts that we're getting are not within industry standards. We found that small adjustment, just dialing those in to where they need to be, make a significant impact on overall rotating assembly longevity. And so today I wanted to show you what Gary's doing, what is required on these fan shafts, some of the things that they do to help us with both new shafts and existing, and why that's important. So Gary, can you give us just an overview of what you do here at Flamespray?
We do basically shaft repairs. Typically 90% of our work is bearing and seal areas where a bearing has worn out a shaft. We can take it down, build it up with a thermal spray coating, then grind it back to size, bring it back in the spec.
For us, you're basically checking our tolerances. And what are you're flame spraying some of those, or
typically we'll set up your parts, we'll check for run out, total indicator reading, and then if the shaft's running out or bent, if it's bent, we can straighten it to some extent. If the bearings run out, we'll undercut, we'll spray it up with 420 stainless, put it in a grinder and grind it back in the tolerance. We'll make it round and bring the runouts where they need to be.
Okay, so let's go take a look inside here, take a look at our fan shafts and what Gary's going to be doing to them to help us repair them and to make sure that the QC is on par with what we would expect. Let's go take a look. So Gary, what are we looking at here? This is a big machine, big lathe.
Regular manual lathe.
Okay.
We use for basically undercutting shafts prior to flame spray. We'll set them up, undercut the area that needs to be flame sprayed or thermal spray coating.
Okay.
Typically, you take it to clean, probably 30 thousandths undersize, so a nice uniform coating's put on. Then it goes back to the spray shop.
Gary, can you explain to us what we were just looking at over there?
That was HVOF coating being applied to a turbine shaft, the tungsten carbide. It's using liquid fuel. Actually, that's the gas.
So he was heating it up, and then he was checking the temperature.
He was actually, there's a powdered carbide being introduced into the flame, actually, and then it's being applied to the part. He's checking temperature to make sure he's not overheating the part. So at times he may have to set down, cool it off, and respray some more on top of that.
And that particular piece was actually, you said, a steam turbine?
That's a steam turbine.
And what are the tolerances on something like that, and what kind of environment is it in?
Something like that, tolerance typically is, 0.5 of a thousandth. Runout's the same.
So it's a high-speed component.
High-speed component.
And the coating that you're putting on it, is that just because of corrosion, or what's the properties of it that
it's tungsten carbide. It's a very hard coating. There's some corrosion properties to it. The engineers at the manufacturer decide what they put on it. I'm just putting on what they tell me to.
Yeah. Well, let's go take a look at some of our fan shafts that we have lined out, and we can show you what we've got going there. So, all right, here we are. We're looking at an 18-foot long cooling tower fan shaft we took out of a Baltimore air coil cooling tower. This is about 20 years old. It's a hollow shaft with solid ends on the side. So we're going to rebuild it because it still has some life left in it, and we can save some money over replacing it with new and actually get a higher quality product when we're done. So Gary, tell us what you're going to do with this fan shaft.
After the initial inspection, we found the journals are running out compared to the body.
Okay.
And because it's a hollow shaft, we really don't see straightening it being a very viable option. So we're going to undercut the two journals on the end, take them 30 thousandths under on diameter, spray them up with 420 stainless, and we'll regrind the two journals. And also we're going to grind the fan tips themselves, because the shaft itself is oversized, and we'll grind that area to the journals to make it round and everything running good.
So I noticed some corrosion in here. This corrosion is typical when you get water infiltrating fan shafts or high levels of moisture. You're going to get corrosion underneath the fan tab connections, and you're going to get corrosion you can see within the body of the fan shaft. You can't inspect that in the field without disassembling that fan and looking underneath just by the way it's constructed. The second thing is, so Gary's going to take that down for us, make sure that that area is round. We can come in and coat it if we need to, and then we have a great surface to reconnect the fan wheels on it. These shafts are so long, Gary was pointing out that, so if I were to put pressure here just in holding it, it's going to show up on your instrumentation.
It'll show up on the indicator in the center. You can actually push on the shaft and you can get it to run out, so to speak.
So they're kind of difficult to check
so
and get
inspecting something like this, you want to make sure you're rotating it from the end of the shaft so you're not introducing any deflection in the body while you're trying to inspect it.
The second thing you gotta be careful of is we have to design specific rigging for this type of shaft so that we don't put unnecessary torque on the ends. This shaft actually gets lifted up vertically and run through an exhaust chase in a building. And so we have to be able to get that up and move it, tip it throughout the building without causing problems. So rigging it and accessing the equipment is a great place to damage your fan shaft if you don't get it set up just right, because we hate to have them do this work and then have to do it again. Once we put it back in the cooling tower, then we do another vibration analysis on it to make sure that everything is lined up and correct. So that is a larger example of one of the larger shafts you're going to see on cooling tower type equipment. These are actually new shafts that we brought in for some of the air handling equipment. Well, that's kind of an overview of the process. It's important. It affects the longevity of the product. It's something that should be looked at in specifications, particularly if it's critical equipment. And then when you're, on the construction side, when you're putting them in, you have to make sure that, you use care. Don't beat on the ends of them with a metal mallet when you're trying to, place them and other things we have seen. So I think that this is going to end up being a good quality product to get put back in and hopefully get another 20 years out of it. Something to consider in retrofit and refurbishment is that QC process. Take a look at what you're getting, both new and used. So that wraps us up for here. Gary, thank you. Appreciate it.